So who here has actually done the government qualification, the reinitialize and depower electric vehicle systems? Everyone's done it? Yes, half? All right, cool. All right, well that just means that we'll have to make sure that we cover everything here just to make sure that we don't leave anyone behind. But before really touching any of these vehicles, I guess we need to go through a bit of housekeeping about things that you sort of need to have in place prior before you are going to carry out this sort of work. So number one is making sure that you're certified. The certification will go through a lot of the safety things. That'll be, for instance, things like if you've got a pacemaker, you shouldn't be working on these vehicles because the electromagnetic interference from the inverter or the higher current and voltage can interfere with that. So we just want to make sure that if you've got that risk, then best not to work on these vehicles. Also, before you get into it, making sure that you've got all your PPE ready. So that will be your Class 0 1000 volt rated gloves. That'll be steel cap shoes. Sorry, not steel cap. Poly. Yep. So steel caps are actually not recommended because over time they can wear through, and then you've got essentially a bit of metal on your feet that can actually go through. So it's actually making sure you've got the composite style ones. Also, safety glasses are a big one as well. If you do wear reading glasses or something along those lines, having something that's non-metallic, or if you have metallic ones, making sure that you tape it to your head. Because essentially what you want to do is if you're looking over something, you don't want the glasses to fall off and then potentially short something. And then the last thing will be any other things. So for instance, belts, watches, rings, necklaces, pretty much any sort of metallic item that you would wear as jewelry or on your person. Ideally, when you're doing this, well, not ideally, you should not be wearing it. So I'm not going to be touching the vehicle here, so I'm going to keep my watch on. But Asher here will be doing the demonstration as we go ahead. Now, before we start touching the vehicle, we first need to mitigate some risks. So you'll see here that we've got some barricades up. So the barricades are here, so then everyone in the area here, or for instance, if you're at your workshop, everyone knows that you're conducting some work, high voltage work, and they know not to come into the area unless they need to. It's a nice visual cue. We also put up signage, so for instance, ones like this, which also say that there's high voltage work's been in the area. So that just essentially is to try and mitigate and stop anyone coming into the area and touching the vehicle unless, well, they shouldn't be. We just want to make sure it's as safe as possible for the person working on the vehicle. That'll also include potentially, like in this vehicle, we've actually got a high voltage sign on the steering wheel as well. And that's just in case someone, for whatever reason, doesn't see this and walks in and tries to start the vehicle, or maybe try and move it where they're trying to put an accessory on or something along those lines to move the vehicle out of the bay. They know, oh no, there's this high voltage works going in place there. So we have a few hierarchy measures that we use to make sure that even if you miss one, there are other backups in play to make sure that the person working on the vehicle is as safe as possible. So once you've essentially mitigated the risks surrounding the vehicle, that can also mean, for instance, if there was a vehicle in this bay where maybe the technicians got coolant or something on the ground, you want to make sure that if something happens here, you want to have a nice quick getaway where you're not going to run into another problem. So making sure that your surrounding area is also controlled and gives you a good exit route is also necessary. But now, once that's all done, now we can actually turn our attention to the vehicle. So once we've gone, yep, we have mitigated all the risks, now we have to, we know what the work is, we know we've got to switch the battery out, we've tested that, we've tested the systems, now we need to turn the vehicle off, now we need to get the key, put that either into an EMC insulated little pocket, which you can get, or you can use a lockout box, which in this case is going to be a shelf over there, just to make sure that the key can't be detected by the vehicle at any point. Now we're going to turn our attention to the actual vehicle itself. So one thing you're going to do is you are going to see many different makes and models of vehicle coming in. And the first thing you should do, and this is covered in the training, is always refer back to the manufacturer's specifications about how to depower the vehicle. So that will be the 12-volt system where your service plug or isolating switch is located, and then also how long you'll have to wait once you've depowered it before you can start working on that vehicle. So it can really depend on what vehicle it is. In this vehicle, we've actually disconnected the 12-volt already, so we don't have to wait that time, just to try and speed it up a bit more. But for this vehicle, it's 15 minutes. Now, it might be different for this vehicle, and it's probably going to be different for that truck as well. So whenever working on this sort of stuff, always refer back to the manufacturer's specifications about what those exact times should be and where this equipment is located. So Asher's just going to go through now. He's just popping off some of the trim before he puts all his safety gear on, just so we can see exactly where the battery is in this case. Thankfully, the Camry 50, this is by far the most popular one, but it is also one of the easiest to do as well. So this one, once you've done all your safety power down procedures, you're only going to be talking about, half an hour max to do this job. Whereas some of the other ones, so for instance, like your Lexuses or those imported steamers, they can be up to the sort of 6-hour range, so much, much longer. But thankfully, the ones that are most common are also the easiest to do, which is what we like. So you want to show the 12 volt there. So the 12 volt is definitely disconnected. You can see it is there. Now, all being mechanics, you obviously know which side of the terminal we need to be disconnecting, yeah? Positive or negative? Cool. So now that that is disconnected, Asher's going to go and pull out the service plug. The service plug in this vehicle essentially splits the battery pack into halves. So each half of the pack is now isolated from each other. But even though we've done that, once Asher gets a bit further in, he'll still do a check just to make sure that the voltage is indeed depowered, because you might have a stuck relay, you may have damage somewhere, you might have an isolation fault where there could be water ingress or something along those lines. So we never assume anything, particularly with high voltage. We always have to check. Did you check your gloves as well, Asher?
I did.
You did, awesome. While Asher does that, I might actually quickly show you also some of the gloves that we use. So Asher's got some normal work gloves on at the moment, which is his sort of general sort of style ones that you'd use for a brake, sort of brake system. We also have your class 0 ones that we were talking about before. Now we test these ones before and after. We use them each time. We're just pretty much trying to see if there is any holes in them or if they're damaged in any way, which I'll show you the test in a minute. And the last part is the leather protected gloves. So we use these ones, particularly when you're lifting try and get the battery out of the vehicle. You don't want to be using these because that's got sharp metal objects and you'll just cut straight through these and you'll be up for another set of gloves. So it really depends on what you're doing. If you're just pulling out the hardware like Asher's doing, the normal gloves he's using is fine. When you're doing the depowering or anything sort of that you think is related to the voltage, then you use these, and for handling you use these. As I was saying, you've got to do a test on these pretty much every single time you use them. So each one of these has to conform to the Australian standard and also an IEC standard. Each one is dated, so the date's stamped on the bottom of them there. If they're brand new, you've got 12 months before you have to get them rechecked, and then it's 6 months thereon after. So they actually have to be sent off-site for testing. But every time you use them, essentially you just pinch it like that, roll it up, and then you're going to pretty much squeeze on it. I mean, I've got a bad seal there. And make sure that there is no air escaping from anything, because then I know, yep, there's definitely nothing happening out of that. So with the Camry 50 series, it's a pretty straightforward battery swap. You've pretty much just got your trims, you've then got your ducting, electrical components, and then structural bolts that are holding it to the vehicle. Trims are very easy. You've pretty much just got the back one here and then the base, so the mat. The inside, you need to pop the base of the seat out and then just put the seats down, and then you can access all the hardware required. Asher's just going through now. and removing the structural bolts. There's 4 on the back and then 2 on the front. And then essentially the battery is free in that sort of regard. On this vehicle, these are also used as commercial vehicles a lot of the time. And well, commercial vehicles, you have a lot of rear passengers, right? And you get a lot of passengers coming off the passenger side of the vehicle because they're stepping off the curb. They're not usually stepping in from the road. So this door here is highly used in a commercial vehicle, in a taxi or something along those lines. The intake is actually right there. It's actually right here. So you're pretty much rubbing up against the intake as you get in and out of the vehicle. Now, people that go into taxis, there's the actual intake itself. So that just sits like that. And then that goes and sits on top of that fan like that. But as you know, taxis aren't the cleanest of vehicles. So pretty much every single time someone gets in or out, they're rubbing up against it. So hair, jumper fluff, boogers, pretty much anything gets sucked up into that filter and gets pretty much put onto the battery. So usually if the vehicle is a 50 series and it was made after 2012, it's got a filter that sits on this piece here, which is just behind this vent here. Typically taxis or service manuals don't cover this because the very first of the 50 series didn't have a filter, so it's not covered in the original service manual, so it doesn't show it as a serviceable item. And because a lot of people didn't update when it was the 2012 to 2013, not a lot of people know that the filter's there. So pretty much just make sure that that filter's clean, because if it's not, it'll block it up and then it just suffocates. It's like trying to have, 5 or 6 face masks on and try and go for a run. You're struggling to breathe and you just overheat and collapse, essentially. So one of the things we actually do as a bit of a tip and trick, you might have noticed, but our filter is actually on the outside of the vent here. And we've done that purely to help out the commercial operators. They clean the back of these vehicles out very frequently. And because cleaning is so important, what we did is there's actually just 4 little screws on the back there. You can pop that out, put it through, and then just put it on that side there, which means that the operators actually can just quickly clean it as they go. And that means that the batteries last longer. So there is a little few tips and tricks, particularly if you show that to you might not show that, for instance, to a private customer because that's not required, but if it was a commercial customer, for instance, you'd show that, and then it shows that you're actually looking after them, and it builds a relationship at least. Yes, definitely. I was waiting for you to pull one off. So this is the service plug from this vehicle. You'll actually notice on top of the service hatch, which usually sits on top of here, I'm just going to use this battery instead because it's a bit easier for me to show. There's a service hatch that sits here, and you can also see another one of the plugs here. But there's these little orange plugs that they're on top of the vehicle. These are essentially a little safety clip, and the whole idea is the tool's actually on the end of the service plug here. So you can actually see it's got a little bit of a nipple there, and you can just put that onto that and then undo it, and then this clip comes out. So essentially, the whole idea is this service plug has to be out in order for you to pull that clip off and to access the relay terminals. But I'm happy for people to have a look on how that works if you want to. Now you can see Ash is down, so what he's doing at the moment is he's just checking the 12 volt. Now he doesn't think the 12 volt is bad, but he is doing what we call a dead live test. So he's verifying that the multimeter works before he is checking the terminals of the battery, and then he's also going to do one straight after to verify that the multimeter is still working. So that once he does that, he can be certain that the battery does not have any voltage in it and it is safe for us to handle. Now this particular battery we're actually not going to pull in and out of the vehicle purely because you've got to get a bit of the lift equipment in, and we're trying to do this as a demonstration, but we're going to get it to the point where it is ready to come out, which is pretty much now. So now you'd pretty much just get either what we usually used to do was a wooden board or a Perspex board, and then just sort of line it in the boot and then slide it up, and then you can use your lifting equipment to get in and out of the vehicle. This one in particular, each module is roughly about 1.1 kilos. There's 34 modules there, so that's roughly 38 kilos plus the tinware. You're looking at probably about 45-ish, you know, as a, you know, estimate. So it's something that 2 people is required to lift it in and out if you're going to do that. Or if you're going to do a lot of them, then maybe you might look at, for instance, getting some lifting equipment that could do the job also. Most of them are either 34 module or less, so most of them are going to be roughly around that sort of 50 kilo mark. There are a few exceptions, so for instance your Toyota Crowns, Lexus GS, and then the Toyota Esteemers, you're going to be up near the probably 70-ish kilo mark. So that's where you may have to look at lifting equipment, or you may have to, for instance, try and split the pack apart if required. So for instance with the Esteemer, you can actually pull the battery pack into 2 pieces. So then you can pull it apart in separate pieces to make it a bit easier to handle. So you'll also, if you haven't done a battery swap, you might not have seen it, but the terminals here that Ash is on top of, you've got the 2 terminals that he's just plugging in, and then you can also see there's a metal tab at the back there as well. And it's just going on to the tinware. Does anyone know what the metal sort of tab there is? So essentially that metal tab connects to a sheathing that is going around that cable, and it is to earth out any penetrants that come into contact with that cable. So if you're going to get, it's pretty much on all the HV cables actually, so the ones underneath the vehicle, the ones here, and then the ones under the bonnet as well. But yeah, if something pierces that cable, it's going to earth it out to ground before it's going to get in contact with the HV system. It's to try and, yeah, make it as safe as possible. So the car's got something called, if you look for it in hybrid control, shortwave highest val, and it's how the vehicle measures essentially isolation faults. Isolation faults are quite a serious thing, but essentially what it means is that there is high voltage detected in the chassis of the vehicle. Ideally, the 12-volt system of this vehicle and the high voltage system of this vehicle should be completely separate from each other and should not be interacting. So the 12-volt, like a normal car, you've got your positive and then your earth is the chassis of the vehicle, and then your HV system should be fully insulated. It should not be in contact with that chassis at all. So an isolation fault essentially is the vehicle saying, hey, we're detecting HV in the chassis somewhere. That can happen for a few reasons. That could be, for instance, something shorted out. On the older vehicles, we've seen detailers high pressure engine bays, and they short out the air conditioning motor because the air conditioning on this vehicle is also high voltage. We've seen stuff like that happen. You can also see water ingress. Sometimes with the electrolyte on the older vehicles, sometimes that can cause an issue as well. It just depends. If we had an isolation fault or some description in that case, we should be able to detect it in that initial testing. What you can do, I don't know if Asher did it or not, but you've got the metal terminals that are in the service plug there. You can check each side of it and just check it to the chassis or to the metal case of the battery. And if you've got nothing on both sides, then great, you've got no isolation fault. If you've got 100 volts there, then you go, oh, okay, well, why have I got 100 volts there? So now you might have to you're going to start treating this battery completely differently because now it's not safe to work on. So you're either going to try and mitigate that as best as possible. You may also bring in a second person as a spotter. You might bring in some additional safety equipment and try and deal with that directly. You're not going to be wanting, if you know there's a problem there, you're not going to be doing that by yourself anymore. Now you're going to have to get a second person in to help you assist with that. Just in case something happens to you, you need to have someone there ready to render assistance. So typically once the vehicle's depowered, you typically wouldn't need a spotter. It's if you have to do, if the vehicle is still operational or alive, or you have to do, because sometimes it does happen, sometimes you have to do a live test or something along those lines. If you're doing that, then yes, most definitely you will need a spotter there. It's really about trying to mitigate the risks where applicable. I mean, if you go back to the Australian standard and also the, well actually mainly the Australian standard, it's written by health and safety experts, and that's fantastic. A lot of the stuff makes a lot of sense. Some other stuff in the real world doesn't make 100% sense. So it's about trying to apply it as best as possible in the real world and just using common sense. So mitigating risk is really the aim of the game. And as we've been talking that entire time, Ash is almost done. He's just putting the trim back in. He's already got the bolts in, he's already got the connectors in, so pretty much once he puts the trim back in and then we can re-energize the vehicle, then all that's left to really do will be to turn the vehicle on, make sure it actually powers up. You'll know if a hybrid vehicle powers up because it'll have a ready light on it. So particularly, it was quite funny. Some of the older taxi drivers I used to deal with that would jump into hybrid vehicles for the first time, they'd go, "Joel, this vehicle keeps stalling on me at lights." It was just, the hybrid vehicle turning off because it didn't need to be on. So essentially the way you know is if that ready light is illuminated, that means the vehicle is essentially ready to drive. So that's the light you're looking for. And you'll see that across a lot of vehicles. So not just hybrids, but EVs, pretty much any electric vehicle has something that will, a ready light that will show you exactly when it's ready to operate. Yeah, I haven't seen a vehicle without it. So for instance, our BMW, which is around here at the moment, that has a ready light. All the Toyotas have ready lights. This has a ready light. So that's essentially what you're looking for. And the ready light also means that the HV system is armed as well. So once that ready light is illuminated, that vehicle is operational. So if it's going to be running at 350 volts, there's going to be 350 volts in the system. So when we're talking exclusively, I'm just going to talk about the hybrid product range at the moment, the nickel metal hydrides. Coda racing, in the real world, you probably won't need to do anything because you've just disconnected the 12 volt anyway, so there's going to be no codes. Even if there was a code there prior, it's not going to be there now. And there's no programming or anything required with this vehicle. So you don't need to program it in. When you're talking about the EV side or lithium batteries, they do have to be programmed in. So if you swap one out, you're going to have to do some sort of reset and recalibration of it. But with nickel metal hydride, not the option, not the case, sorry. Now, one other quick thing that I'll quickly note as Ash is at this point in time, particularly if you haven't done a hybrid battery swap before, is the service plug and the essentially latch that locks it into place. Yeah, if you can quickly show that, that'd be great. So you may see on the very left-hand side here, but there's a little white plug that's up the top there. That essentially is telling the vehicle if the service plug is in or not. So essentially in the service plug, it's just got a little jumper pin. So, yep. So essentially in the plug, there's a little jumper pin and that just completes the circuit and it lets the vehicle know that the service plug is installed. Particularly if you haven't done a hybrid battery swap before, you might just put it in, but unless you lock it across, the vehicle won't start because it'll see that, the open circuit there and go, nah, service plug's not in, even though it may be in. So just as particularly if you get a code called P0A0D and you've just done a battery swap, check that first. That's most likely what your problem is. Getting the battery in and out of the vehicle, usually, sometimes the agricultural methods are the best, so even just using blocks of wood is okay. It's also non-conductive. The only thing is you just don't want something that's got high friction because then, the battery's not going to pull. You're just going to pull whatever you're trying to brace it with plus the battery. So we actually used previously, we had a Perspex board because the Perspex board had a really low friction point. It was quite durable and it allowed the battery to slide very easily. So we use that. Also, when you're putting it back in, you could pretty much just put the battery onto that and it would slide back down into place as well. Then it makes it very easy for someone just to go onto the other side and then do the final positioning to get it all to line up with the bolts. But it may vary slightly depending on which vehicle you're doing. I mean, the newer models, they don't actually have the battery located here in between the boot and the rear seats. They've actually got it located under the rear seat. So for instance, your newer Camrys, Prius Cs, some of the new Corollas, they're actually all under the seat. So really the lifting requirements change depending on what the vehicle is. So Ash has now completed everything. He's now re-energized the vehicle. So he's put the service plug in and he's reconnected the 12 volt. He's now gotten into the vehicle and he's going to check to see if the vehicle is happy. Considering the vehicle started up, it's happy. So if you wanted to be very, very thorough here, you could potentially then go and get a scan tool, verify there are no faults, and you could also do a quick drive cycle and see if everything's operating as per normal, making sure that the battery's charging correctly, discharging correctly, air conditioning is working, that sort of thing as well. It's really about, well, what you'd be doing with a normal vehicle whenever you're doing a service plan or fixing a fault, is you're verifying that the fault was there prior to the work being carried out, and then you've fixed it once the work's finished. But yeah, that's the entire swap.